Welcome to Unstuck. Today, maximum subarray, find the contiguous chunk of an array with the biggest sum. We'll write the slow, obvious way, then build Kadane's algorithm one line at a time until it's ON. Beginner friendly and we'll go slow so every line makes sense. The problem, LeetCode 53, given an array of numbers, some positive, some negative, find the run of neighbors that adds up to the largest total. For -2, 1, -3, 4, -1, 2, 1, -5, 4. The best run is 4, -1, 2, 1, which sums to 6. And the trap that makes this classic interview question is arrays that are all negative. Hold that thought and drop a like if you want the clean version. Let's start with the obvious approach. Now, the obvious way, just try every possible subarray. Pick every start, pick every end, add up the numbers between them and remember the biggest total you ever see. It definitely works, but the number of subarrays grows with n squared, so it gets slow fast. Here it is in Rust. The outer loop picks the start index I, where our subarray begins. The inner loop extends the nj from I onward. Each step we add nums at j to a running sum and update best. So for every start we walk every possible n, that's the n squared work, 2 nested loops over the array. It gets the right answer 6 on our little array. But on 30,000 numbers, the 2 nested loops take over 200 milliseconds. Let's get that to linear time. Kadane's insight is beautiful. Walk the array once, left to right, keeping a running sum. The key realization, if your running sum ever drops below 0, throw it away and start fresh. Why? Because a negative running total can only drag down whatever comes next. You're always better off starting again from 0. Let's build that, line by line. First variable, current, it holds the sum of the run that ends right here at the number we're looking at. It starts at 0, an empty run. Second variable, best, the largest sum we've seen anywhere so far, and notice this, it starts at the smallest possible number, I 64 min, not 0. That one detail is what makes all negative arrays work. We'll see why in a second. Now they loop one number x at a time. First line inside, add x to current, we extend the run ending here by the new number, that's it, one addition. Second line, compare current against best and keep the larger. So every single step, if this run is the best we've ever seen, we record it, nothing gets missed. And here's the short trick, the last piece. If current has gone negative, reset it to 0. We drop the losing run and start a fresh one at the next number. 3 lines inside the loop, don't extend, record, and drop if negative. And that's the entire algorithm. Run it, same answer, 6 on our array. The all negative case gives -2, which is correct. More on that in a moment. And the 30,000 numbers, 18 microseconds versus 200 milliseconds, one pass instead of n squared. Let's trace it by hand. -2, current goes negative, best is -2, we reset. 1, current 1, best 1. -3, current negative, again reset. 4, current 4, best 4. Then -1, 2, 1, build current up to 7, and best becomes 7. Watch how every time the run turns sour, we cut it loose and let the next number start clean. Now the trap everyone hits. If you start best at a 0, an all negative array returns 0. But 0 isn't in the array, there's no empty subarray allowed. Because we start best at negative infinity and record current before resetting, we correctly return the least negative single element. -8, -3, -6, -2, -5 gives -2. Start best at 0 and you'd get this wrong. So the common mistakes, starting best at 0, resetting best when you meant to reset only current, and dropping the negative run before you record best, which loses the answer on all negative inputs. Order matters, extend, record, then reset. The scorecard, brute force is n squared. Kadane is linear time and constant space. One pass, 2 variables, no extra memory. On our benchmark, that's about 11,000 times faster, and it's the textbook example of trading a clever insight for a whole order of complexity. Recap, keep a running sum, record the best as you go, and drop the run the moment it turns negative. Start best at negative infinity and record before you reset. Extend, record, reset. That's Kadane's algorithm, order n in one pass. Quick one, if these help you, the wallet's on screen, and there's a coffee link in the description. Every tip funds the next one. The full Rust code is in the description. If this helped, hit like and subscribe. A new coding challenge every day. See you in the next one.